Hello Internet, this is the High School Scientist, and in this video we'll take a look at angular velocity and angular acceleration. In my previous video we dived into velocity and acceleration. So watch that video before continuing with this one. Okay, so let's start with angular velocity. Now we know that velocity is the displacement of an object over some period of time. But when we deal with angular velocity, we have to consider the motion in a circular path or around an axis. For example, we have an object rotating in a circular path. So now, how do we measure its motion to say how fast or slow the object is rotating? We can measure its rotation by measuring the change in angle that's occurred in a period of time. Or in other words, we can measure the velocity at which it's rotating by knowing the displacement of the angle with a change in time. And here we have arrived at the expression of angular velocity, which is angular displacement by time. Now let's imagine that an object moves along a circular orbit and it takes 2 seconds to complete one rotation. We can say one rotation amounts to 360 degrees, and so it covers 180 degrees per second. But we cannot call it degrees per second since the unit for angular displacement is radians. We denote it as radians per second. That is, the disk is rotating at 3.14 radians per second. And check out my video on radians if you don't know what it is. I'll mention the link in the description below. So now that we know what angular velocity is, let's also take a look at its uses. We can determine at what speed your car is traveling, how long will the earth rotate, the magnetic field strength of a planet, etc. Yes, these are pretty complicated concepts and we will learn about it in my later videos. But for now, we should move on to angular acceleration. Now, the same concept applies to angular acceleration. We know that linear acceleration or acceleration in a straight line is velocity by time, which means there is an increase or decrease in velocity with a change in time. But here we are dealing with angles and not distances. So we have to modify the expression by eliminating velocity and instead including angular velocity. So the expression becomes angular velocity by time. Now for example, we have an object which is rotating at an angular velocity of 10 radians per second. 5 seconds later, its angular velocity has increased to 20 radians per second. Now this change in angular velocity over some period of time is what we call angular acceleration. I hope this explanation helped you to understand, but if you're still confused, I'll be solving questions based on these physical quantities in my upcoming videos. And that brings us to the end of this video. I hope you learned something, and if you did, just spread the word, let your friends and classmates know about this channel. This is the High School Scientist signing off.